So we were looking last time at separable equations here, separable differential equations. This was our first solution method, and let's go back and review. So a differential equation here is separable if you can write it as dy dx is an equation in x divided by an equation in y. And the good thing about that is that if you cross multiply, you'll get g of x dx is h of y dy, like this. And then you can integrate both sides. So if the two functions are equal, their integrals are equal. And then we said, well, you know, this is an integral dy and this is an integral dx. How can you do that? You know, we're integrating with respect to different variables. Well, remember the differential of y is just f prime of x dx. So this y is in f of x. So what we're really saying is that we're integrating h of f of x, this is our y, times f prime of x dx, that's our dy. So we really are integrating both sides here with respect to the same variable x. So let's look at an example here. Example 1, we want to solve the differential equation y prime here is x cubed over y squared. And so the first thing that we got to do is take this y prime and write it as dy dx. So dy dx is x cubed over y squared. Now we are going to set the cross products equal. So multiply both sides by y squared, right? And then multiply both sides by dx. So you multiply by the denominators. And then the dx cancels out here, and the y squared cancels out there, and that's the same thing that you get from doing cross products. So we then know that y squared dy is x cubed dx. If these two functions are equal, their integrals are equal, so we integrate on both sides. And the integral on the left hand side is just power rule, that is y cubed divided by 3. Integral on that right hand side again is power rule, x to the fourth divided by 4, and we actually get a constant of integration on both sides, but we're going to bring those constants of integration over on the right hand side and combine them and just call them c. So now we want to solve for y here, so let's multiply both sides by 3. So 3 comes in times the x to the fourth over 4, and 3 times the arbitrary constant. And then these guys cancel on the left-hand side. So your y cubed is going to be 3/4. I multiply the 3 in. 3/4 x to the fourth. And then 3 times arbitrary is still arbitrary, so we just call that plus c. And then we want to take cube roots on both sides to undo this cubing here. So this then gives us y on the left-hand side. So y, which is really y of x, a function of x, is cubed root of 3/4 x to the fourth plus c. Now what's that constant? Well, we got to have more information to get that constant. So what if we were given that y of 0 equals 4? So this is our x value here. So when x is 0, y is equal to 4. Well, we can plug that in. So we're going to plug that into this equation. So y plug in 0, we're going to plug that 0 in here, 3/4 times 0 to the fourth plus c, and that's got to be equal to 4, that's this 4 here. Well, 3/4 times 0, that's 0, so this is actually the cubed root of c. So that tells us the cube root of c is equal to 4, and then we want to cube both sides, and the cube and the cube root undo each other, so we're left with c is 64. Now we can take that 64 and plug that guy back in here for c, and we have a specific solution. So our specific solution is y is cubed root 3/4 x to the fourth plus 64. So this is what's called the general solution, when you've still got a parameter left in there. That's our general solution. And then this is a specific solution given this initial condition. When you specify an initial condition like that, a condition at time 0, that makes this what's called an initial value problem. So now you should be able to work on WebAssign problems from section 9.3 here, problems 1 and 2. So try WebAssign problems 1 and 2, and then move to the next video.